So if we look at this term right here and take the derivative and pull it out, we can end up with an equation that looks like d by dt, and then d by dt again. And here we have the sum of mi ri right here. This is the sum of mi ri as a vector. But if we look at sum of mi times ri, that's equal to the mass times the center of mass. So this is d by dt of d by dt of m times the center of mass. So this is m times r. Now we can see that this is the same as d by dt of m times v, where the derivative goes through the mass and is the derivative of r. So we have to find basically the velocity of the center of mass is dr dt. Now we have this, which is of course the momentum of the system. That's equal to the external force. So the movement through this equation of understanding how the system as a whole can be considered a system with total momentum, total mass, a total position in a certain sense, where this is the position that represents the whole system, and a velocity of that center, which when multiplied by the mass becomes very useful. We could write P also. P is also equal to, total P is m times v, which is very useful. And that means that the entire system can be treated, this whole system, as though it's one object. And we add up all the masses and we get this one mass. We look for the position and we get this one position. You can say, well, of course this works out. No, it doesn't necessarily work out. It turns out in relativity that this doesn't work at all. And that's because in relativity, each one of these particles has a different time that goes with it, because time becomes slowed down or dilated when we go faster. So if some of these particles are moving, then in fact, as they move, their time is different. And so we don't have one time that we can use to take the derivative. So this whole argument falls apart in relativity. So we should be very thankful that it works well when we have a non-relativistic situation. So in the end, our P is equal to the mass times velocity for the whole system. This is the mass, which is the total mass. The center of mass is given by this equation. I ought to put it out there. And the velocity is equal to the rate of motion of that center of mass. And finally, of course, dp dt is equal to the external force and not depending at all upon the internal force as we showed earlier.